Okay, so now let us discuss about the graphical representation, domain and range of the function tan and its reciprocal cot. So this is the positive direction of x-axis, this is negative direction of x-axis, this is positive direction of y-axis, this is negative direction of y-axis. Let us divide this x-axis with an interval of angles of pi by 2. So this is pi by 2, this is pi, this is 3 pi by 2, this is 2 pi, and it continues like this. And in the negative angle it is minus pi by 2, it is minus pi, it is minus 3 pi by 2, it is minus 2 pi, and it continues like this. As long as the value of tan is concerned, here it is 1, we can measure along y-axis 1, 2 like this, and in the negative side it is minus 1, minus 2, and it continues like this. Now, if we see the different values of tan and try to plot this in a graph, it looks like this. Okay, so what is the value of tan 0? Tan 0 is 0. And what is the value of tan minus pi by 2? Is undefined. And what is the value of tan pi by 2? It is also undefined. Okay, so these are the lines, x equal to minus pi by 2 and x equal to pi by 2. So the point is that the value of tan 0 is 0, the value of tan pi by 2 and tan minus pi by 2 both are undefined. So how we can draw this one? And another point is that in this range minus pi by 2 to pi by 2, tan is always increasing. Okay, so if we represent these three statements, what are those statements? The value of tan 0 is 0, the value of tan pi by 2, tan minus pi by 2 is undefined, and in the range minus pi by 2 to plus pi by 2, the tan is increasing. If we consider these three statements, we can give a pictorial description, which is a graph of tan like this. So you see, this graph, which I have written in red color, is actually increasing. At the point 0, its value is 0, and it is never touching these 2 points, minus pi by 2 and pi by 2. That implies what? That x equal to minus pi by 2 or x equal to pi by 2, both lines are the asymptote to the curve whichever I wrote in red color, which is the tan curve. Similarly, between pi by 2 to 3 pi, how we can draw? In a similar manner. Okay, in a similar manner, between between pi by 2 to 3 pi by 2, we can draw like this. We can continue this line pi by 2 here. We can continue the line 3 pi by 2 here. Sorry. Okay, so how it looks like? It looks like this. Correct? Similarly, between 3 pi by 2 to again 5 pi by 2, it will be like this. And in the negative side, how we can see? We can see like this. We can draw a line x equal to minus 3 pi by 2. And we already drawn the line x equal to minus 5 by 2, but let's extend it in the positive direction of y-axis. So the curve looks like this. Clear? So what we observe, the domain of this function tan by looking into the graphical representation, we see that the function tan can take any value from the real line except pi by 2, 3 pi by 2, in the similar manner 5 pi by 2, 7 pi by 2, 9 pi by 2, and in the negative angle minus pi by 2, minus 3 pi by 2, minus 5 pi by 2, minus 7 pi by 2, minus 9 pi by 2, like that. Except those angles, it can take any value. So what does it mean? It means, in a very simplified statement, the domain of the function tan is any real number except the odd multiple of pi by 2. Whatever I said in English right now, how you can represent in set notation, here it is. So for tan, what is the domain? Domain is any real number except means the difference r minus 2n plus 1 into pi by 2, where n is any integer. And what is the range? Range, we see it is any value from minus infinite to plus infinite, which is the set R. That is minus infinite to plus infinite. Understood? Very good. Okay, one more thing is that I should say that function tan is always increasing. You see, it is always increasing in this range. Correct. Now we are going to discuss the graphical representation of the reciprocal of tan, which is cot, that is 1 by tan. Let's see how it looks like. So this is the positive direction of x-axis, this is negative direction of x-axis, this is positive direction of y-axis, this is negative direction of y-axis, and let us make an interval like the same thing what we did for the other trigonometric functions, the angles within. Let us divide the angles with an interval of pi by 2. This is pi by 2, this is pi, this is 3 pi by 2, this is 2 pi, and it continues like this. And in the negative, here we see minus pi by 2, it is minus pi, it is minus 3 pi by 2, it is minus 2 pi, and it continues like this. And let's see the values of this function cot, and let's measure the values along the y-axis. So this is 1, this is 2, and it continues like this. And in the negative side, it is minus 1, it is minus 2, and it continues like this. Okay, now give a thought. If the tan curve looks like this, how the cot curve can be looks like? Okay, so what is the value of tan 0? We know the value of tan 0 is 0, but what is the value of cot 0? It is undefined. 1 by 0 is undefined. So what we see is that in that point 0, the function cot cannot actually touch that line y-axis. And what is the value of tan 90 degree? That is pi by 2. Tan 90 degree is undefined, but cot 90 degree is actually 0. So it looks like the curve will be like this. Okay, let's draw it. Okay, so So this is the y-axis, that is the x equal to 0. This is x equal to pi by 2. So the curve will be looks like this one. Again, it will never touch the point pi and 0. So it never touch the lines x equal to pi and x equal to 0. While in both these values 0 and pi, cot is undefined. Alright? And it is decreasing, you see, it comes like this. Again, in the similar manner, between pi to 3 pi by pi to 2 pi, the curve will be looks like this one. Let's extend that line x equal to pi, and here it will be 2 pi. Okay, the curve will be looks like this one. Correct. Here also we see decreasing. In the negative direction, how we can find it out? We can find it out in a similar manner. This is x equal to minus pi. So the curve will be looks like this one. Okay, and in the similar manner, it will become minus 2 pi by 2 with this. So if we extend minus pi like this and 2 pi like this, the curve will be like this. So what we observe, what is the domain and range of this function cot? So we see the function cot can take any value except 0, pi, 2 pi, in the similar manner 3 pi like that, and here minus pi, minus 2 pi like this. That means domain is any real number except the integral multiple of pi. So how we can represent? We can represent here. So what we see is that cot, its domain is any real number except integral multiple of pi, where n is any integer. And what is the range? What is the range? Range we see is that it is any real number, right? Any real number it is getting covered. So if think in another way, the range of the function tan is real number. So its reciprocal it should also be a real number. So from that theoretical knowledge you can also tell, yes, the range of the function cot is a set of real numbers. And here also from the graphical representation you can see it can cover all the values in the real number. The value which will be returned by the function cot can be any real number. So what you can say, the range is R. Clear? The last point about cot is that it is a decreasing function. Alright, it is decreasing. Unlike tan, which is increasing. Fine? Thank you very much. So in the last session we will discuss about the domain and range in a tabular format so that you can memorize it very clearly. So meanwhile I will tell you, just spend couple of minutes understanding the graphical representation of tan and cot and their domain and range. Thank you.